Good afternoon, everyone. My name is Ajayi, and today I will be presenting my project, LogicHouse, and describing the process of creating this project. Without further ado, I'll go straight into the topic. The topic is the development of LogicHouse, a digital game-based learning tool for digital electronics, and I had the privilege to be supervised by Professor Adetiba and Engineer Fiji. Today, I will be introducing you to my project, setting the problem that I'm trying to solve, my aim and objective, the system and my implementation of this project. And I'll also be discussing my plans for further works and concluding on my project. First of all, before I go into this presentation, I'll be defining three key words that will come up across this presentation. First of all, I'll be defining game-based learning. And game-based learning is the use of games or gamified elements to educate children or a classroom. And serious games is this genre of games that are designed specifically for education and not entertainment. And digital game-based learning is just a subset of game-based learning, which says that it's specifically using only games that are digital, games on laptop devices, and not physical games like card games or table games. So I'll go straight into the introduction. Engineering is the currency of the world, and one cannot exist without it. And like all currency, of course, engineers have to be manufactured. And for engineers to be manufactured, we need engineering education. Now, the problem is that across the world, you can see that engineering students are losing motivation and are getting bored in classrooms because if the IN translates into the classroom, people are dropping out because of how difficult it is, and people that are even in the class are having low success rate and they are lacking motivation, and the teachers and students can't seem to relate with one another. This has led me to the aim for my project, which is to design and develop a serious game targeted at teaching digital electronics to students in the Electrical and Information Engineering department in tertiary institutions using digital game-based learning. My objectives are to design and develop a serious game prototype that can be incorporated into a game-based learning classroom, evaluate the developed prototype using the design model as an assessment tool, and deploy this prototype to an online platform. Of course, before I go into creating this project, I had to review certain game-based learning tools that have been used across the world, and we can see that across the world, people have implemented game-based learning in engineering. We have in the USA, where Apple created Digital Island for digital electronics using Kernel maps, and same thing will happen in Italy, and in Taiwan we have the operating system for computer engineering classrooms, same thing in Spain, and Austria and UK and Dubai. So this goes to show that in every single continent right now, game-based learning is applied in the engineering classroom. So it doesn't stop us from applying game-based learning into the Nigerian classroom. So, like I said earlier, the assessment tools are necessary for me to decide if my game is relevant enough to be introduced into the engineering classroom. And I looked at four major game-based learning assessment tools. That's the Game Object Model by Amory, the Retain Model, the Killed Experiential Gaming Model, the Learning Game Mechanics Game Model by ARNAB. After considering this four, I settled on the Learning Mechanics Game Mechanics by ARNAB, and this is why. By ARNAB separated the learning mechanics and the game mechanics and decided that it pointed out the specific game mechanics that occur in games such as role play, cutscenes, action point, game turns, tutorial, reward, protege effects, metagame, and also things that occur in learning classroom. That's guidance, instruction given by the lecturers, identity plan, modeling, assessment, competition amongst the students, responsibility, accountability, and motivation, and even tutorials that teacher gave, such as examples that happen in classroom. And it goes to create this table that is separated into the 6 thinking tools. That's the creating, evaluating, analyzing, applying, understanding, and retention. And you can see that it groups each of the game mechanics, learning mechanics, and maps them to a thinking tool, a thinking skill. Now we can say that a student has to create the memory, evaluate it, analyze it, apply it, understand it before it can retain such a memory to apply in other classrooms. And with this table, we can point out when your game has a certain mechanics, and if it correlates to a mechanic on the learning table, then you can say that you have particularly solved a thinking skill for the student. So the goal of this project is to make sure that I cover all 6 thinking skills and make sure that the student understands the game. So like I said earlier, digital electronics is my focus course in the Department of Electrical and Information Engineering, and the topics I picked were Boolean algebra and the number logic system. Now, LogicHouse is a 2D serious game because this game is specifically for education and not entertainment. I use the client-server architecture because I use an external playfab, an external server, this is the playfab, to analyze the scores and the metrics of my game, while the client, which is itch.io, is where my game is hosted. The tools I use to develop this project is Unity engine as my development engine, C# as my language, Procreate for the art, and also Adobe Illustrator for the art. Microsoft Azure Playfab is my client, and itch.io, like I said earlier, is Microsoft Azure Playfab is my server, and itch.io is my client. So the sequence diagram for my game is that there are 3 major classes in this game. That's the user, the game, the system, and the playfab. So the user logs in and is authenticated on playfab, and if it's successful, the game is allowed to start. So the game system here is itch.io, and the student can play the game between itch.io, and if it gets the score, itch.io sends this value back to playfab, so it's stored in the database, and the student can access the score at any point. Of course, when the student requests for the leaderboard, he has access to a score that is stored in playfab, which will now be reflected on the game system. So in relation to ARNAB's map, I'm bringing out one level here, and I'm pointing out the 7 steps that occur in my game, which is the briefing, the game starts, the level tutorial, then the player getting desired value, calculating feedback, and when I go into the map now, we would see that I had matched things in the learning mechanics to the game mechanics. Take for example, briefing is A and 1. So in my learning mechanics, A means instructional guidance, and in game mechanics are relating to goods and information and cutscenes. If we recall earlier from the table of the thinking skills, by the time I go to reflect to see that I'll probably have catered to a particular thinking skill. Same thing with the main part of the game, which is getting the desired value, collecting the values from the player, becoming a value. So that's D, B, A, and 4 to 5. And we can also say that D is question and answer in learning mechanics, and also question and answer appears in the game mechanics. Also with 2, we have that an action and task gets a token for the player in the game mechanics. For the last one, when it comes a value, which is A and 5, an assessment is an assessment in game understand. So the player is assessed, and this score is what is sent to the leaderboard, and we will see this here in feedback and mission complete starts, which is motivation, responsibility, incentive, action points, competition, and the status of the player. So I'll go straight into the flowchart of this game. This game, you start and you come across the login page, which authenticates that you are a student. So if your password is correct, you get to the menu page, and in the menu page you get to select the leaderboard or the settings, or you go to the next scene where you can play this game. And when you enter the room, you go to each room, any room in the house that you see. Like I said, the name of my game is LogicHouse. So when you go to a room, they are faced with certain steps that will lead you to play the game. All of this which end up leading to the player score at the end of the game, and the game ends. But before the game ends, the leaderboard is updated to have the current score of the player. So I will go ahead and play my project now and run you through the process. Of course, if you want to play this way, you can visit the link below, bit.ly/LogicHouse, and you get to see the game and also play for yourself and get to interact with the game in terms of digital electronics. Now you see that the player is logging in and creating an account. So the player's name is Moshakwe, and she's creating an email and password, and also testing so she can log into the game. Of course, I will just talk about LogicHouse briefly. LogicHouse is simply a house that is in darkness. The power is out, and because the power is out, the player has to go in and fix the house. So he has to go into each of these rooms so he can fix the house, and then the player can have house in it. So in this level that he has selected, he has to play the laws of Boolean algebra, and the game mechanics is so simple. When you hit a player, you become that player, and because of this plus and where the plus represents or and the star represents and, he has to pay attention to the laws of Boolean algebra that has been taught in the classroom, where 1 + 1 is 1, and if you hit another player like 1*1, obviously it'll be 1 because it's 1 and 1. And the rules of and in terms of Boolean algebra is that everything is 0 apart from 1 and 1, and for plus everything is 1 apart from 0 and 0. So as the player goes on, we should also take note of what he's doing. The game is to become 1 in 45 seconds, so he has to make sure he doesn't come across anything that disrupts that. We can see that he became a star because he came in as a. So yeah, so now we're going into the multi-choice question, which interacts with his knowledge of the number system. So you can see that the question, the product of sum, can be implemented using, and the player is tasked with finding the correct answer to this question. If he gets correct answer, a score is added to the this. If he doesn't get it, of course it remains the same. So clearly he didn't get the previous one, but if he gets it, the score is added, 10 points is added, and becomes 40. So the logical sum of two or more terms is sum of products. The Morgan law states that. So all of these are just taught in the simple classroom of digital electronics and as introductory classes. Now once the player does all of this, of course with time, once you practice this every single time, it becomes familiar with the questions, and by the time it gets to the exam hall, it finds it easier to answer this question. That's kind of the goal of the game. Now we can say the house is lit up because this current game has 2 levels, and he has successfully finished the 2 levels in this game, and the house is all shiny and bright and new. So now we can see other people that have played the game before. We can all see their scores across range, and people that have not played the game, that probably didn't fill any username, are blank. So that brings me to the end of the display of this game. Thank you. So as this game went on, I implemented and tested my results up with students, and I asked a particular question that now that you know what game-based learning is and you've played this game, would you like this game to be implemented in your classroom? And we had a large percentage interested in this game being implemented in their classroom. Also, when implementing their classroom, and also when we asked that any improvement that they have, they also had good reports. Very few people, like we can see from this selected response, only one person had a lower percentile of an opinion of game-based learning being introduced in the classroom. So in conclusion, we can say that commercial games can be applied to engineering education in Nigeria, and this shows that there are creative ways and more fun ways that learning can be interesting and inclusive for students, and also repair the relationship between lecturers and students. And also what this just shows is that it's possible to implement game-based learning, and there are other approaches that can be taken by educators and learning, such as the game development based learning, which is the use of when students create a game to solve a problem, and in the process are made to learn the topic. Because if you're creating a game on a topic, I had to learn digital games when I was creating a game on this topic. And also gamification, which is simple points and reward system that we have in our Moodle platform. For further works, I would like to introduce other topics in digital electronics to this game, such as game maps, also things like number conversion and all those things, and also simple things like the, a greater implementation of the Morgan law. And also I would like to compare this method of teaching to other game-related method of teachings and see which has the greater impact in the students' life. And also, are educators receptive towards this method of teaching, or would like to stick to the traditional based method of teaching? Thank you. And if you have any questions, drop them in the comments below and we will get to it.